Good day, math learners! In this video, we will talk about the concept on similar polygons. What are similar polygons? Two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. Let us take note the following. The statement corresponding sides are proportional, it means that the ratios of all the pairs of corresponding sides are equal. When two figures have the same shape but may differ in sizes, they are said to be similar to each other. And lastly, two shapes are similar if one shape can become the other after resizing and possibly after rotation, translation, or reflection. Consider the pentagon ABCDE and pentagon FGHIJ below. And let us now identify the corresponding angles and corresponding sides of each figure. So using the figure ABCDE and FGHIJ, so we will have the following corresponding angles and its vertices. So we have the corresponding angles, angle A and angle F, angle B and angle G, angle C and angle H, angle D and angle I, angle E and angle J. And also its corresponding sides, we have segment AB and segment FG, segment BC and segment GH, segment CD and segment HI, segment DE and segment IJ, segment AE and segment FJ. The corresponding angles are congruent. The ratios of the corresponding sides are equal. So we have the following representation wherein its corresponding sides or the ratios of each corresponding sides are equal. So we have segment AB over segment FG, that is equal to segment BC over segment GH. And that is also equal to segment CD over segment HI, equal to segment DE over segment IJ, equal to segment AE over segment FJ. Hence, the corresponding angles are congruent, and its corresponding sides are proportional. Thus, pentagon ABCDE is similar to pentagon FGHIJ. Determine whether each pair of figures is similar, then justify your answer. First given figures are a rectangle and a triangle. The two figures are not similar since they are different shapes. They differ from the number of angles and sides. A rectangle has 4 sides, at the same time it has 4 angles, whereas the triangle has 3 sides and also 3 angles. Let us now consider the two given rectangles. So we have rectangle ABCD and rectangle FGHE. So in this case, the two rectangles are not similar since the corresponding sides are not proportional with each other, and even if the corresponding angles are congruent. So in this case, to show that the two rectangles are not similar, so first we have to check if the corresponding sides are proportional using the means extreme product law. Then let us now identify the corresponding sides. So we have segment AD over segment EH, and that is equal to segment AB over segment EF. And then substitute the measure of each side. So we have 5 over 4 equals 7 over 8. Then cross multiply. So we have 4 times 7 is equal to 5 times 8. So it gives us 28 and 40. So as you have noticed, the two values are not equal. Thus, we can say that the two rectangles are not similar, since they are not proportional, even though their angles are congruent. Suppose we are given two triangles. We have triangle ABC and triangle DFE. So in this case, the two triangles are similar since the corresponding angles are congruent, and at the same time, its corresponding sides are proportional. To show that the two triangles are similar, so first we have to check its corresponding sides. So we have segment AB corresponds to segment DF, and that is equal to segment AC over segment DE. Then substitute the measure of each side. We have 3 over 2 equals 6 over 4. Then cross multiply. We have 6 times 2 is equal to 3 times 4. So that is 12 equals 12. Then we also have another proportion that we need to consider. So we have segment AB over segment DF, that is equal to segment BC over segment EF. Then substitute each measure. So we have 3 over 2, and that is equal to 3 square root of 3 over 2 square root of 3. Then do cross multiplication. So 2 times 3 square root of 3 is equal to 3 times 2 square root of 3. Then it gives us 6 square root of 3. That is also equal to 6 square root of 3. Thus, we can say that the two given triangles are similar. In continuation with the previous slide, so we have shown that the corresponding sides are proportional. This time, let us show that the corresponding angles are congruent. So let us now then check the corresponding angles. We have angle B congruent to angle F. So in the given figure here, so they are both right angles and each angle measures 90 degrees. Then for angle C, that is also congruent to angle F, angle E rather. So angle C, which measures 30 degrees based on the given figure, and also with angle E. So the two angles are congruent. And lastly, for angle A, which is congruent to angle D, so that is equal to 60 degrees. And how did we come up with 60 degrees? So angle A is equal to 60 degrees because the sum of the interior angles in a given triangle is equal to 180 degrees. So we have the measure of angle A plus the measure of angle B plus the measure of angle C. Same will follow for angle D, which is also equal to 60 degrees. So the sum of the interior angles, angle D, F, and E, so that is also equal to 180. Then since we have the measures of angle F and angle E, so we have 90 and 30 degrees, it gives us 120 degrees. Then 180 degrees minus 120 degrees, it gives us 60 degrees. So both angles are equal to 60 degrees. Thus, it gives us corresponding angles which are congruent. The quadrilateral ABCD is similar to quadrilateral WXYZ. Find X, y, and segment wx. To solve for x, so first we have to identify the corresponding sides. So we have segment AD corresponds to segment WZ, and that is equal to segment BC corresponds to segment XY. Then substitute each measure. So we have 10 over 5 equals 20 over x. Then cross multiply, we have 10 times x is equal to 5 times 20. So we come up with 10x equals 100. Divide both sides by 10. So the value of x is equal to 10. To solve for y, so again we will check the corresponding sides. So segment AD corresponds to segment WZ, and that is equal to segment AB corresponds to segment WX. Then substitute each measure. So we have 10 over 5 equals 44 over 3y plus 1. Then do the cross multiplication. So 10 times quantity 3y minus 1 equals 5 times 44. Then distribute 10 to the quantity of 3y minus 1. So we have 30y minus 10 equals 220. Then transpose negative 10 to the right side. So transpose negative 10 to the right side. So we have 30y equals 220 minus 10. Then simplify 220 minus 10. So it gives us 30y equals 210. Then divide everything by 30. Therefore, the value of y is equal to 7. Thus, segment WX is equal to 3y minus 1. Since we already have the value of y, which is equal to 7, substitute y with 7. So we have this 3 times 7 minus 1, 21 minus 1. The segment WX is equal to 20. Always take note that all congruent polygons are similar, but not all similar polygons are congruent. Again, all congruent polygons are similar, but not all similar polygons are congruent. And this ends our lesson on similar polygons. Thank you.